Good morning. Welcome back. This morning we're going to concentrate on ParaView again, and then only in the afternoon we'll look at visit. We'll do some cherry picking. We'll do a few things from visit which are complementary. Because I mean we've talked about grids and mesh and Python and all this. More or less the same thing applies in visit, but there are some unique features of visit which we will look at. First of all, we need to go to client-server connections with ParaView. The very first thing we're going to do is do it on your laptop, just so that you understand things. So this is what we'll do. On your laptop, you should have an executable called PV server. Find where it is and run it. Launch it. And it should print out the message waiting for client connection with the name of your laptop and a default port, which is 11,111. Accepting connection. Then you will start ParaView itself connecting to localhost. So connecting to itself. And that should result in the message client connected, and you should have a live session. So that's the first thing to do. Go to your bin directory, identify where the PV server is and where the ParaView server is. Okay, everything good? Yeah, good. And once you have that, you're free to display your favorite data. Okay, run PV server and connect ParaView to itself, to the local host. So all this on the same machine. Again, like I said yesterday, for the rest of the morning, I urge you to create SSH keys so that you don't have to type unless you like to type passwords all morning, but please create SSH keys. If you have SSH copy ID, you use that to copy it over. Otherwise, you copy it to your home directory on ELA, and then from ELA, you cut it with 2 arrows here onto the authorized key file. This will be useful because as soon as we know how to do client server locally, we will go to date. Yes?
When you're on your way.
Oh my gosh, oh my gosh, yes. Socket called Ushti. PV server.
Because I can start ParaView like
Can you, so this is Ubuntu, can you SSH to localhost? This would be the first thing to do. Okay, type yes. You can't SSH to your own thing. That's interesting. So type a password. Yes.
I'm getting, so if you want to, so the server looks okay here,
Yeah.
right? And so I tried localhost, I tried with the port name without.
Okay. So the first, if you have some errors, like for example U2, it might be that you cannot SSH to yourself on your laptop. So first thing to do from a terminal, try SSH localhost. This is SSH to your own machine. Just make sure that works. Okay.
It's supposed to work without password, right?
Yes. It would be preferable.
So I put my own.
So you put your own key in authorized keys. All right. So SSH localhost or SSH 127.0.0.1. It's the same person. It doesn't find localhost.
No, it doesn't. No, it doesn't find DB server on my machine. It's in the app form. Yeah, I'm looking in the contents in the contents in the bin. I found it in the bin. Okay.
You've managed.
Weird that it doesn't find it.
Okay. Anyone has other issues like that? I'd rather. Okay, here's what you can do. So, no, I didn't set to type 1111.
Yeah, but
Just remove the 11 thing. Yeah.
it doesn't change the thing.
I can't read, but okay, let's do that. Open, add server, localhost. Try type localhost. Okay. Configure, manual, save, connect. There, we're connected. Should the direct thing fail, there is another option, which is to define a localhost entry in your connection menu. So if you follow my mouse pointer, here I go to connect, and I have localhost here. So if you don't have it, you say add server, name localhost. You leave everything else as default, client server, etc. And I will show you mine now, edit server. It's like this, configure. This is manual. You leave everything else, save there, and you're done. At this point, you can double click on localhost to connect to himself. This might be a way to avoid the other errors. I'm going to assume that the majority of you have succeeded in doing that. Because now we're going to move to Daint. No, good question. There's a new file under in Daint under user gfar project ParaView called ParaView tutorial day 2.pdf. Thanks for asking that. All right. Connecting to Daint is going to be an extra step. And the instructions for Windows user are on the presentation, and for Linux users are here. Actually, I have added documentation to the web page this morning. So if you refresh your browser here, we really should have all the documentations we need. The very first thing we need is a host file, and that host file you will find at this address. This is a profile for Daint. You will need to copy this locally to your laptop and then load it into ParaView. Loading it into ParaView is done in the following way. You go to the Connect menu over here, and you say Load Server. Okay? So I'll give you some time to do that. Copy this file somewhere on your laptop and then load it into ParaView. Yes. The second step is we need to generate a Slurm job. Slurm is the job scheduler on Daint. This particular script here will be called by ParaView. You need to make a copy of that, a private copy of that script somewhere on Daint. The easiest place is your home, because ParaView will call that particular script to generate the batch job for Daint. So I'm speaking slowly to give you time to do those two particular steps. And with some of you, we've already done all this yesterday evening, so we should be ready to go. I hope it still works from yesterday. I didn't touch it during the night. I didn't touch anything.
Where's the link to this page?
The link is in the presentation. I apologize if you didn't see me click. Instructions are found here. So if you have the PDF file, if you click on here, it opens up the web page. I will most likely repeat this a few times because people work at different speed. So it's okay. I will go on, and then I will repeat in 5 minutes time for others. So here's now my ParaView on my laptop. If I have loaded the Daint profile, I have here something called reverse connect Daint. I will double click on it. Here's where you need to be careful. Let's select just one node. Here on the PV server port, you need to put your Unix ID. Each of you must have a unique number. The best way to find a unique number is to pick your Unix ID. Interesting. If you followed what I said, you copied that particular file, apps Daint ParaView, to your home, you need to modify the address of that particular script to your home. And once you have that, you're ready to go. So if you watch what I do, I'll click OK. My goodness, I don't expect that. Once you attempt to connect to Daint, you should see on your screen this pop-up window with the content of the S batch of the Slurm script submitted to Daint. And indeed, we see that we have selected one node, 8 tasks, 59 minutes of runtime. Once you're connected, you should see here on your left side of the screen localhost 1100, which is my user ID. That's a proof already that we are connected because it says CSRC, which means client-server remote connection. And a further proof of being connected in parallel to Daint is to go about ParaView, and here we see that we have 8 processes and a remote connection that is open. Yes, the password is the same as yesterday. It's plus CPU plus GPU.
Yeah.
Remember?
But it's not giving, I do now.
Okay.
It's not giving me the opportunity to put a password in.
Did it work yesterday?
Yeah, I will keep it.
It must be the phase of the sun
Yeah.
around. on date, if we look at the reservations, we have this course reservation, okay, that is reserved for all of us, so all the courses account. Now, unfortunately, I made a mistake. I mean, the web page gives you the standard reservation, the standard queue, which is called viz. But today, this morning, exceptionally, we're using viz course. So you're going to have to modify in your private copy of the file. Unfortunately, it's written in red here. It doesn't show very well. Let's do it like that. There we go. This is the line up here on your screen, which you will have to use. You'll have to use the viz course reservation. In fact, this is exactly the purpose of copying that file to your home, is that you can modify it. Another modification you can do is you uncomment those two lines such that you have an output and an error file written by the batch job. And here, of course, you change my name by your username. Okay, Andreas? This is the file. This is this file here, which I instructed to copy to your home directory. I've now made the correction into that file for the viz course. So all you would have to do is correct for the error and the output of the Slurm job. Let me repeat a few things here, because still some people are a bit confused. That first thing you don't change. That you put your course ID. This should be your SSH path. In this case, I'm on the Windows, so it's p-link. This should be your private copy on date of that particular file. So it should be /home/users/course and your number. I recommend you set that to 1, because otherwise we will not have enough notes for everybody. This should not be touched. And by the way, you must use version 4.3 on your laptop as well. Otherwise it will not connect. This should be your Unix ID. And by the way, we are SSHing to this particular address. So from a terminal window on your laptop, make sure you can SSH to that address without errors. Because otherwise it's independent of ParaView. This is just an SSH problem. Okay, that's the preliminary. Once you submit, the first confirmation should be that you have this message on your screen popping up, and it should show you the batch job that has been submitted. And then you give it a little time, because it doesn't always respond quickly. There we go. And how do I make sure that I am connected? There are two ways to make sure. You look at this address right here, follow my mouse cursor, it shows CSRC, which means Client Server Remote Connection. It shows localhost and it shows your Unix ID. And then the second way to make sure you are connected is to go about and you look at the connection information, and it should show that you have 8 processes and you have a remote connection right here. Remote connection, yes, 8 processes. Okay. But really, the fundamental things are here. All those arguments need to be right. That's the first step. Yes? Okay, okay, it's possible. Yeah, good. I think you're good. I think you...
Yeah, I saw that about it's coming.
So it works?
Yes.
Yes.
This is done.
Okay, good. So perfect. Congratulations.
Thank you.
You can go have a break and have coffee. No, now you need to work. Source, wavelet, apply. I'll let you do the work. Apply. Where's the apply button? You don't have it. It's because you're missing the pipeline browser, which is no, you're missing the properties. Properties, apply. There. Now you change this to surface, and you display your your process ID. Oops.
How did you manage? How did you manage?
So the one which you
Okay, you guys, is it working?
Okay.
Yes, you're perfect. It's running. Yeah, it depends. It might be a special keyboard I have on my laptop. Okay, it's working fine. You can close this.
Okay.
You connected. You do it. You do a source wavelet. Wavelet. Apply. Go to the properties. Properties. Apply. Okay. Change the display to surface. Change the color to processor ID. Processor ID. And there, you're running in parallel. Okay. Very good. Congratulations. I'll come in. You have it?
ParaView just crashed.
Okay. Okay, good, good. Have you installed the new version? And it worked. Good, I need to know that. We're still fighting with the password.
Yeah, I copied the key.
I'm going to help you. And you? Okay.
I did copy on my home directory.
Yes, yes.
And
Change that 8 to 1 because otherwise it's too much. Okay. Okay, type OK. Okay, so this is an SSH problem. It's nothing to do with ParaView. You need to make sure you go to a terminal, make sure you can SSH to the machine directly from your laptop. From your laptop.
Yes,
So exit ELA. Exit ELA. Okay, there. You try SSH course at date 101. Oh,
101.
yeah, actually, dot login,
Like this?
dot login, no, dot login dot CSCS.
Like this.
Yes. Yeah, type yes. Okay, good. Now try again the connection to ParaView. Okay. We still have this little exchange error. Close. Go back to your terminal. try the same SSH but to Ella, not to Daint. Without login, without the login thing. Ella. Ah, interesting. Interesting. Ah, here everything really should be ready. And this is Ella. Okay, control D. Course 69. That works fine. Control D. Daint. This works fine. I would be tempted to close ParaView, yes, and restart it. Okay, open the dialog, the connect dialog. Connect. Show me all those parameters. Expand the window if you can, so that I can see all those. Okay, course 69, user course 69, one. Everything looks good. Type OK. All right. It's working.
Yeah, it's working.
Oh, thank God. Go back to your terminal. There is an issue with Ella. So, you see? Yes. Oh, sorry. Type yes. Okay. Control D.
Sometimes it is broken, yes.
2 dot. No, 2 doesn't exist. It's 2 login dot. Oops. Dot. No. You need to try them all. You see?
Actually, I think it's
Yes.
3 which connects.
You don't know. Okay, exit and now do 3. Yes. Okay, exit that. Now try ParaView again. Connect. 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 Okay. There we go. Don't ask me. It works?
Almost, but no, it's something I load the server, no? So again, and then here I check. So
Okay.
I check that
Okay.
this is in Dane, right?
Okay.
So
Yes.
this is the core.
Yes.
user.
Yes. Yes. Yes.
And now
Yes.
how do you
Yes.
and
Okay. This you don't change.
you
Okay.
check, and the ID is
Yes.
ID,
Type OK.
yeah,
Yes.
and
You
then
look.
okay. And now it's trying to connect. Before it happens this, now it happens this.
Permission denied.
But no, then I get the wireless connection to the CSS.
Yes, you must have CSCS.
Could you have a look at this? So what I got is this one, that username no such file directory. When I try to connect using ParaView, so this was a message. So if I launch again, then I can repeat. I can.
But
arrived, yes.
you're on your laptop here.
It's arrived, so I here load server.
No. I think you confusing things.
Really?
Okay, type connect. Say okay. You start ParaView. You should not start ParaView like you did with a minus server.
You, but that's written on the. That was written on the tutorial.
On the first page, the very first thing this morning. But to connect to Date, we let me say a few more things. Excuse me. Ma non ci credo. Okay, let me words. There was one person here which had a lot of SSH key problems. It actually happens quite a lot. You need to make sure this can work reliably. The problem is the following. When you SSH to Ella, Ella has actually 3 different synonyms, aliases. One of them is alias Ella1, the other one is Ella2, Ella3. We resolved the problem, and he was able to successfully connect to Date by making sure, first of all, from a terminal, that this would go through without errors. If this goes through, then it resolves those SSH key authentication problems. All right. You try this, and perhaps a few more people will get forward. I have to continue before we'll make a pause. We're going to talk about a few more tools which we will need. So pvbatch is what we're going to use to submit batch job on Daint or on your own machine for that matter. PvPython can also be used to test a particular Python script. However, it's pretty lame as an application. It doesn't have a graphical user interface. You can't even move the window around. So you'll see it's of limited use. pvbatch is the batch-oriented tool, and it can run in parallel, and it will be used in many cases. For example, if you have multiple time steps in a transient simulation, if you have different input data sets to customize an animation, and so forth. So to use pvbatch, you can reload a script generated with ParaView, or you can give it a handwritten script. That's up to you. Reloading, we've seen how to do this. There are two different ways to load a particular state in ParaView. There's the so-called state file, which has a PVSM extension, and my advice is to not use it. Actually, my advice is to use it once, and then to edit the file. And then you understand why you should not use it, because it's unreadable. Okay? It's just one big, long mess of instructions, and there's no notion of the pipeline. The pipeline is the natural way that we have to think about our visualization. We have a source of data, we have some filters, we have some mappers, etc. All of this disappears completely from the state file. So I never use state files. It's there. I use Python scripts because Python scripts are readable. We've seen how to reload the Python script using the Python shell. You can also start ParaView with the option -- script equals with the file name. There's no space here. It's script equals the file. If you put a space, it doesn't work. There's a demo that you could try to reload. It's located in lib, ParaView, etc. And it does exactly those 4 commands. But because it's so short, I'm going to type it on the screen to show you how it works. So you get your ParaView. This is on your laptop. You get your shell, and then you type sphere. There, you have a sphere. Nothing on the screen because there's no rendering yet. Then we'll type shrink. Nothing on the graphical window yet. But you see the pipeline is being built. Then I create the viewable object with show, and then I render. And I have a sphere which has been shrunk to visualize the different elements there. So this you can do on your own laptop. Sphere, shrink, show, render. There's your pipeline. Very, very trivial. I'll go back to my PowerPoint presentation. I've taken a shortcut in my demo. I didn't give names to those objects. It's a good habit to actually give them names such that you already have the object you need for further manipulation. Okay? There. And now we're going to go to our pvbatch example in parallel on Daint, and you're not going to do a live connection, so it's going to be much easier. You're going to SSH to Daint and execute this. By the way, I'm preparing you for a big exercise, which will come after the break. So I hope we get through this. Here's our sphere. We're going to run it in parallel this time. And we're going to visualize the sphere cut off in different slices among the processors. So there it is, sphere. You don't have to type all of this, okay? The file is already ready for you on date. We'll set a resolution of whatever number, 100 is good. We'll use the process ID scaler to color it. We'll show it, so this is it, showing the color of the processor. Just to be able to scale the colors to the right number of processors, we'll get the number of processors as the active connection get number of data partitions. And we'll set the range of our color table from 0 to the number -1. We'll make a color table, blue to red, with a minimum and a maximum. We will color by the process ID. We add the scalar bar. All of those things you can get from the trace command, okay? You don't have to invent it. We'll set the view. And then this one we haven't seen yet. We will write the image. We give it a file name, and we give it a writer. If we want PNG, we use VTK PNG writer. If we want JPEG, we use JPEG, and so forth. And this is our image. And this is how we will execute it on date. Module load ParaView. AP run. In this case, 16 tasks, 8 tasks per node. We'll run pvbatch. We'll use that particular flag, and we'll give it the Python script. All of this is prepared for you in this directory: apps, date, ParaView, colorsphere.sh. This is the script to submit to sbatch, and the script loads, does exactly this. Okay. With a small difference. So as always, you copy that to your private home, so then you can modify it. Okay. Here I have tentatively commented out the reservation. So you'll have to remove one of the pound sign, one of the sign here. It's not pound, to make sure we use the reservation. And this otherwise is ready to go. Okay. Yeah, and optionally you can also set the output of the batch job, of the Slurm job. This you do not touch unless you change the number of nodes and the number of tasks. In this case, we're using 8 tasks per node. Those numbers have to be scaled. The other modification you will need, because you don't have permission to write the image in my directory, you will change, of course, the Python code at the very end. At the very, oh, actually, I think I made it smart. It writes the image in your Scratch directory automatically, because it uses base name. And I'll show you base name. Actually, let me quit. Let me make a copy of this. Before you make a copy yourself, let me make things simpler. we don't need all of this stuff. There we go. So I get from the environment the variable called scratch, and this is your private scratch. So it works for every user without any changes. And at the very bottom, I write the image to scratch plus a file name. And this will write 3 images. I just simply change the orientation of the sphere in space. So let's try to execute that. You copy those 2 files, color.sh and color.py, to your home if you want, and then you submit the batch job. Submitting the batch job, I hope is obvious to all, but perhaps not. You sbatch the script just like that. There's my job running. And in my scratch space, I should have 3 images, colored sphere 0, 1, and 2. Remember to load the ParaView module. Okay? There's no good time and there's no bad time.
There's bound to be some stupid thing in that part, but it's just like that. I've shown it to other people and I seem to
Okay,
have done
just do the connect thing. Okay, so core 62, yes. What's the address of this? That's your own. Good, good. 8, good. Okay, type OK. Yeah, okay, so that's the standard thing. Go back to your terminal.
This is the next thing.
Yeah. If there's SSH problems, from your terminal, you need to be able to do those SSH commands I printed.
Yeah.
Have you tried that?
Yeah, seems to work to the login and
Show it to me.
I'm just trying to find the appropriate window.
From a terminal on your laptop. Exit from ELA. I want to see.
It's SSH. Course.
Exit from ELA. You're not on. You
sorry.
on ELA. Exit. Okay, I want to see those SSH commands.
SSH. Course 62 at
62.
At Daint or
At ELA. ELA 1.
login?
ELA1.login. Login.
Jesus, the pressure. Login dot
CSCS. Let's see it.
.ch.
Okay, and this is the first problem. Yes.
I did that
Mhm.
already.
Okay, exit. Do the same for ELA2.
All of them.
Yes. All of them. Yes. Exit.
3.
ELA3. I'm not sure if I've done an exit.
I didn't do it for all of them.
Well, that's what I said to do,
Okay, so
and
I
now
was-
now you do Daint. Just show me
I think I
Daint.
did Daint.
Okay, try ParaView again.
Okay, thanks. Sorry, it would be my stupid fault. I'll just restart this. Because
Yeah, it's good. Might be a good idea to restart. You all have an image? You don't.
No,
anything, this is the error log.
So you are here. Module list. Time is loaded. VTK with. I hope it doesn't.
the connection.
I hope it doesn't interfere. Have you copied those colored thing? Here, yes.
Yes.
Okay.
But I'm not there. I'm still doing the connection for my.
Oh,
I'm still at the connection problem.
oh, I see.
Yeah.
So this you haven't done yet.
Well, I edited it, but yeah.
Colored data sh. This course. Let's change partition to normal. Oh, actually, you need to uncomment the reservation. Uncomment the reservation, and then submit again. Yes. Okay, that should be all. That should try it with this. Submit. No, so then change it to normal. Change the partition to normal.
Submission failed.
Yeah, so edit that file. Change that to normal.
And I wanted to ask, is this we change it to user's course or we run it there itself?
No, that's your own. Yeah, that's your own copy, so that's good.
That's okay.
Yeah. Okay.
I'm not listening completely. When you mentioned we should.
Yes, that's
Inco-
right.
I
Yeah,
got-
you need this course.
I changed to my name.
Okay.
I changed this because I copied
Yes,
local.
yes.
Yeah, but he's complaining about my account when I make aspect file. So you said invalid. account.
Okay, so edit the SH file, the colored SH file.
Mhm.
Edit it and change change the partition to normal. Yeah. Equals normal. Okay. And try again.
Okay.
Oh my gosh.
I should see this now.
And you should check the pictures. Wonderful. I see pictures on the screen. Not for everybody. I want to see. Yes. Yeah. Okay. Did that resolve it for you? It's really unfortunate that this is happening. Do you have it? Good. Okay. Okay. All right. I've promised you to take a pause, but you have to merit to. It has to be. Do an SSH minus X to log into Daint. You need to deserve that pause. You haven't deserved it yet. So you need to listen to me for 15 more minutes, okay? I'm going to do a live demonstration, and you'll have to watch it, and then you'll have to replicate that after the pause. Let's go to the ParaView thing. Let's go to the slideshow. There, we're good. So we know how to do this. when you save the Python script from ParaView, it does most everything, but it doesn't actually give you the Python commands to save images or movie. There's a special macro called animateReader, which you will find in the file called simple.py. animateReader is very easy. You give it a time-aware data source, a view, and a file name. And you call it like this: animateReader, the name of your reader, the view, and some patterns of files, TMP. It will just go through the whole thing. So that's what we'll need. It will start at the beginning and run to the end. If you want to modify that, get your reader, get all the time steps values, and do something like this, for example. For I in time step start and increment, do this. You've learned this yesterday. The view time of the view we change, we render, we write the image like this. Now if suppose I have a movie to make with 10,000 time steps, it would take 3 days. I write 10 scripts. Each of them use a different start. I started at 0, then at 1, then at all the way to 9. And then I offset this and I run 10 batch jobs at the same time. And I generate time step 0 to 999 on one job, time step 1,000 to 1,099, etc., etc. So I run massive. I can run the full supercomputer if I have the allocation. Suppose you want to do this with multiple file names, but your file names are not discovered easily by ParaView. Use glob. This is a standard Python package. Files equals glob.glob. The string with the little star or whatever symbol you have. Then you sort your file names, and you'll have the whole list of strings representing your file names. And then you can animate that very easily. Reader that file name equals files with an index, and you render. Okay? For example, and this is becoming the exercise, we're going to read this particular data set, which you will find at this address. You're welcome to copy this file to your laptop because it's pretty lightweight. But it has 46 time steps, so it's interesting. This would be the most trivial script to do. We'll get a view for all the time steps. We'll animate that by changing the view, and we render. Otherwise, we replace this with the macro animateReader, the reader, the view, and then some file names. Okay, this would be the ingredients to use. But the exercise is going to be a bit more complex. And we'll have until lunchtime to do this. We'll read the file. You're going to watch. I'm going to do it. We're going to load the data with a variable called displacement, disp, like this. We'll animate that in the GUI just to understand what this file is about. This is a multi-block data set. So just for simplicity, we're going to extract the first block. That block is called unnamed blocked ID 1. We're going to look at one particular vertex on that finite element mesh, and we want to plot the value of displacement through time at that particular vertex. Suppose you'll see this is structural mechanics. Suppose there's a failure of your model, something breaks or whatever. at that vertex, we want to plot our variables through time and see what happens. So I picked that number because it's a round number. It's easy to type on the graphical, on the GUI. We'll do this, and then we'll do this inside a Python programmable filter. Okay, we'll do this through the GUI, and then we will repeat the experiment through the Python programmable filter, which we learned yesterday. And by the way, since we're looking at the displacement through this finite element mesh, I'd like to see the maximum of displacement anywhere on that mesh. So I'll ask Python to give me that. We'll save the state. We'll reload it with pvBython just to check. We will edit the Python script, add this macro at the very bottom of the file. We'll copy this to date, and we will submit it via pvbatch. And if you don't get it before lunchtime, there's no lunch. So you'll have to, just kidding, you'll have to make it work. There it is. We start ParaView. Hello. Yes, there I am. I read the file. So displacement right here at the bottom of my file, this should be clicked on. There, turn on, and I say apply. There's my model. Pretty boring. Still pretty boring. It's an aluminum can. You know, the famous drinks from the USA, which many millions of people drink. So it's a half can. And there's a big block over here, and we're going to crush this can. Okay? So if I just say play, there it is. We're crushing and we're deforming the mesh all the way to the bottom. All right, this is good for recycling. So there is my crushed can at the very end. I will show the display variable right there. Sure enough, this part of the mesh here, which was at the bottom, has had little displacement because it was already at the bottom, whereas this part here at the top is red because its magnitude of displacement is pretty high. Let's go back to step 0, which is right here. Reset. There we go. Play. Okay, good. Stop here. By the way, under View, we have the time inspector, which is a little window here we have to manipulate the time. So you could easily just go through time like this, changing your cursor. Okay. All right. I'm here. I will extract block number 1, this one. Okay, it's the bottom. It's the aluminum can. Just to show you another feature of ParaView, if on this particular on this particular mesh, there is something you want to look at very precisely. Let me zoom here. You see those particular icons here? They let you select points on the model by pointing at them in the screen. Let me show you. Let me demo that. If I can get out of this. No, not like that. Oh, wonderful. There we go. ParaView. I will select points on the surface right here. I have in purple 11 points that were selected. I'd like to see the IDs of those vertices and the numerical value of the displacement. I open my selection display inspector. I select the display variable to show, and fortunately they're all on top of each other, but we can fix that. I'll make them white to make it easier to read. And more or less, there we go. If I really zoom on, I have the value. See my mesh here. I've kind of lost things. There we go. Here's my mesh. At every vertex on that mesh, I have the value of displacement shown. Oh my gosh, it's hard to see because it's all blue. I apologize for that. Anyway, you can replicate that also on your screen. There is most likely a way to change the display property. If I go here, edge color, I select white. Okay. Edge color. There we go. All right, here's my finite element mesh and those particular vertices. If I go back to my selection display, instead of showing the display, I will show the ID of those vertices. So there, you load your data, you see some, you visually detect some particular problems on your mesh. You want to see the numerical values. That's how you do it. That's one way to do it. The other way we've already learned yesterday is to go through the spreadsheet view, just to remember, just to remind you. And here I have my display and my IDs, etc. So I can go and select a particular. Here, if I inspect my numbers and I see one of them that's out of range, I can click on that and I can go back visually to inspect my mesh. All right. Back to our little demonstration. I will find data. That's my homework. I select ID equals 1600. Okay, I got two answers right here, 1 and 2. It's because I selected the original data set, and this is why instead of that I wanted to use only one block just to make it simpler. So I'm redoing the query. Is 1600. There I have one answer. And I have a button here, plot selection over time. If I do this, it normally runs really well on my desktop, but on my Windows machine here, I'm not sure it actually does. There's something funny about it. But this is what you should be trying at your desk. By the way, index 1600 is right here. So I'm going to visualize the time-dependent behavior of that vertex on the mesh, and as I crush the model, the displacement of at that particular point will be visualized. Okay, we're going to go back to what we learned yesterday. Somewhere there's a numpy array called displacement, and if I index that array by number 1600, I will get exactly the value of displacement at that index. And if I animate all this, I will get a time-dependent plot of value of displacement. This is what I will do. So, I guess I had forgotten to click the apply button. When you plot over time, ParaView does a whole bunch of things, and it's summarized here. For every variable, it finds the minimum, the maximum, the standard deviation, all the statistics you can think of. And of course, it's way too much to display on my limited screen here. I could attempt, okay, all right. Trust me, all of those variables and statistics are displayed on the graph, but it's so many that we don't see them. So here's what I can do. At the bottom of my menu here, I have a list of all those variables. As you can see, they're all ticked on. I'm going to turn them all off like this. And I'm going to show just the displacement magnitude. I just have to find it. Well, I'll just show one. Actually, the standard deviation is not a good one to show. I have to scroll through the list. It's not very pleasant because my screen is reduced. But there, this would be an example. I've selected the minimum of displacement, minimum of magnitude of displacement. So as you can see, as time goes at the beginning, if you recall, that vertex I chose is in the middle. So at the beginning, it doesn't have much displacement until here, and then that displacement just goes up in an almost linear fashion. All right. So here's a plot. You can actually save that plot, and there you have your graph, which is already quite useful. I'll delete this for now on. There is always my vertex here that has been selected. I will get a programmable filter. And if you recall now, so the programmable filter, because it's a filter, it takes multiple inputs. So we need to address the data as input 0, because in this case we have a single input. So the address of it is inputs of 0 dot. The point data, remember the dictionary is called point data. It's indexed by the name of the variable, display. And there's what I'm looking for. I hope you can see it. There. This is the value I'm looking for. In my input 0, the point data, the variable displacement, variable 1600. But I also want to find, for example, the maximum of displacement over the whole mesh during time. I will use what we learned yesterday from VTK.numpy interface, import algorithms as algs there. And I will print two things: the value of displacement at index 1600, and I will plot algs dot maximum of inputs 0 dot point data dictionary displacement. Is that the name? Yeah. I don't know what happened to my laptop here. Hello. Good grief. All right, I'm good. If I say apply, there, I have it. At that particular time step, I have the value of displacement, which is a vector in x, y, z, and I have the maximum of the magnitude of displacement over the global mesh. Now, if I animate this, I'll just get the whole list. Let's play this. There we go. I've just done exactly the data extraction I had in mind. I close this. There, I'm at the bottom of my animation. I save the script, save state. I choose a Python file, and I've already saved it, so I'm not going to do it twice. I quit ParaView. There. For verification purposes, I will run pvPython and the name of my Python script. There we go. There we go. There goes my animation, and the whole list of displacement got printed on the screen. So now you pipe that to a file, you open the file, you save it, and you have your tabular data exactly as you want. And now if you want to use Matplotlib, which we didn't have time to go into the exercise, to do a nice little plot, you have everything you need. How do we run this on Daint? Here's what we do. We edit the file, documents. It's called can.py. Is that right? Yes. There's my script. I need the name of the reader. So I look for it. It's right here. Can EX2, because it's an Exodus 2 reader. That's the name of my reader. Here's the extract block. Okay. We don't have to change anything. Here's my programmable filter, where I print out the variable displacement at index 1600 and the maximum of the whole field. So you do this for 1600, then you do this for another vertex, and you're free to modify that. And I'm done. Oh, actually, I've already done the modification. I add one line, animate reader. It's a named parameter, so I have to say the reader to pass to this macro is called can ex2. There. I'm done. I've done this on my laptop. Suppose you have big data. Here's the trick. You do it with a reduced resolution copy of your data, or perhaps instead of using 10,000 time step, you use just 10 time step to verify that at the beginning, in the middle, and at the end things look good. You test your script, then you copy your Python script without any changes. You move it to the supercomputer. You enable all the time step, or you enable the high resolution mesh, and you run. By enabling, I mean you change the file name, for example, and you submit to pvbatch. And if your reader is capable of doing things in parallel, you enable pvbatch in parallel, and then you run your whole script in parallel. So if I go to Daint, I think I have it on Daint, or maybe not. I don't know if I tested it. It doesn't really matter. You've seen what I've done here. I've run pvPython. You do exactly the same, but you use pvbatch. The difference is when I run pvPython, it opens up the screen and does this, does the window thing. Where is it? There. I don't want this on a batch system. Okay? So Daint will do that for you without opening a window. It will do that on the GPU, but in something we call pbuffer. So it's an invisible buffer. There, we can have the pause. When we return from the pause, you load that data set, you try this plotting, you write up the Python script. I'll show it to you here again on the screen. You save that into a Python script. So I will say tools, Python shell, run script, document scan, just to reload it quickly. See, now I've put the animate thing already in the, so now it does it for me. Close, there I am. So that's the script you want, but then you're free to use your own imagination and do something else. Okay? And this is the complete thing now. We've learned how to connect numpy arrays to ParaView, or to get numpy arrays out of the ParaView object. We use the GUI and the ParaView interactive application to examine our data, to find some features we want to detect. We find a particular problem, we say, I want to look at that particular place in my simulation, and I want to plot that. I get this into a script, I run it. At the end of my script, I have a nice 2D plot displacement at that variable. Okay? So you can start any time or you can go out for a break.